Hey Roy, Meteorologist there in Tuttle, back with you. It is about 5:52. We've had some storms developing out across parts of Oklahoma, Texas, and into southern Kansas, and so we're going to take a look at those. One of them has had a tornado warning with it for about the last 30 minutes across southern Kansas. It has not produced a tornado. I've been sitting here watching it, but we're going to go ahead and bring you up to speed on that one as well. So thanks for joining me. To have a couple of storm chasers out today. And they've been tracking these storms. Let's see. First up, we've got old Jeremy. He's out heading on I-35 north toward the Kansas border, so he's going to try to catch something in that area. We had Chance out there in northwest Oklahoma as well. He captured a teeny tiny funnel earlier on. It didn't touch down, so we're going to wait to see him to get his shot back up. So we've got some guys out there right now. There's a severe thunderstorm watch that encompasses a good part of Oklahoma, Texas, and a little part of Kansas here for the rest of this evening. All right, let's take a look at the radar views. We're going to kind of go around here and show you what's happening. So we'll start you off in northwest Oklahoma first off. This is up around Medford, Renfro, Waukita, so some heavy thunderstorms here. Some of these are severe, producing some damaging wind and large hail, and at times a little bit of a lowering. This one here around Kansas City, well, it has had a little bit of a wall cloud with it. It is on the edge of where the frontal boundary is, so that's why the Weather Service was kind of a preemptive warning just in case it taps into that circulation along the boundary, so that could produce a quick tornado. So right now, even though no tornado has been sighted, that is the area of rotation outlined here by the yellow line. This is passing between our Kansas City and Hackney. So this is just east of Gouda Springs. So we'll keep an eye on this one here as it makes its way across into southern Kansas. Make sure you guys stay in your shelters if you're in the path of this particular storm. Let's see here. Movement on this one is to the east at about 15 miles per hour. We've got our Kansas City, Gouda Springs, and Rutherford Field Airport are the major areas kind of in the vicinity of this particular storm. Probability of a tornado in the algorithms though is only around 2%, so it's not very high. Back here further to the Kansas-Oklahoma border, again watching these guys here, but so far nothing really to be concerned with at this point in time. Okay, so now we're going to shift into southwest Oklahoma. Okay, so southwest Oklahoma, if you head out toward the eastern Texas panhandle, you have this little storm working in from Dodson here toward McKnight, Hollis, and Vincent. Now, this storm actually has some pretty decent low-level rotation with it right around the town of Dodson. So the algorithms are triggering on potential tornadic development within this area of the storm. So this will be coming into our net. So we might get a tornado warning out of this one here momentarily. We'll keep an eye on it. This is coming into Harmon County, though, from the Texas Panhandle, and other storms behind it that are just severe right now. We've had hail so far up to around hen egg size, I think 2.5 inches in diameter. So far it's been about it. Okay, so there has been some big hail, in other words. Now we'll go up here toward the I-40 corridor, right around the Clinton area. Let's see, this particular location marker here said that he had about a 2-minute funnel cloud. Now, a funnel cloud is a tornado that has not touched down. So in other words, when you say tornado on the ground, it's redundant because technically that does mean a tornado. In other words, otherwise it's a funnel cloud. So we've had a funnel cloud here west of Clinton to Stratford, looks like, according to observations from out in the field. Sometimes you have to take these reports with a grain of salt, though, because this network was at one point hacked with some false reports. So we always have to kind of err on the side of caution. We get these out in the field. We'll look at it, see what they say, and then we'll look at the radar view to verify what they're looking at. Right now, I could see a weak wall cloud in that area. Sure, if you want to call it a finger funnel for a little bit, that's fine. There's nothing indicating a tornado at this point in time or anything imminent. But this is for this cluster out here across western Oklahoma, just north of Weatherford to Thomas, Custer City, Arapahoe, Butler, for that activity. So that's the secondary batch. So there you go. You've got 1, 2, and 3 batches of storms. And as we talked about, the Weather Service did issue a tornado warning here. for southwest Oklahoma. So this is going to be for Harmon County. This is for that storm coming out of the Dotson area and McKnight and Arnett. So this is where we'll have our first tornado warning for the state of Oklahoma. It looks like it's actually weakened over the last few minutes, which is good for the body of Oklahoma as it moves into southwestern parts of the state. But for right now in southeastern Texas Panhandle, basically right along the state line, that activity will be looking at potential for tornadic development. So let's do a track on that one. Let's go back down here. All right, so we have, okay, good. There's no major communities involved. It will pass north of Hollis, north of Gould, north of Duke, so that's some good news. Let's see some of the information within this. Hail size up to about an inch, 1.5 inches in diameter. Winds around 70 miles per hour. Hollis, Vinson, Madge, and McKnight are just the communities involved with just the thunderstorm itself for that part of the severe thunderstorm. Now, the part for the tornadic aspect of it, again, same kind of area, moving to the east at about 23 miles per hour. This warning goes until about 6:45. These are pretty slow movers, so we'll have to keep an eye to see if the rotation continues and if it strengthens and or weakens. So this is on the southern end of the stalled front that's across southwest Oklahoma, and that is why they're in that tornado threat right now. Let's see. So there was a storm chase report of a tornado near McKnight. So visually, has been confirmed, looks like, again, if this report's going to be accurate. So here's the McKnight on the map. So they're probably around Arnett, looking west back into it. So that would be a pretty good proximity as far as location goes. Let's see what the data looks like at this point in time. Let's see. I'm going to switch to this source down here. We're going to look at some of the details within this. So we'll keep an eye on all these clusters and see how things go. Radar data is a little noisy in the velocity component aspect of it, so a lot of this is going to be side lobe contamination here. So the actual circulation is quite a bit weaker. It's on the southeast side of Dotson, so it's just crossing over the state line here, just probably seconds away. Let's see here. There's some reports of dust being kicked up and blown around this area. Okay, so here's where the Weather Service just issued a secondary tornado warning, this teeny tiny little box, and that's to cover for the rest of this circulation around Dotson. So let me highlight this here for you. Let's see, we'll do this. So the circulation part of it is real weak. In other words, there is no good couplet anymore for like reds and greens that come together. So it's actually weakened over the last few minutes. When I came on live, it was probably the best it had looked, and since then it has not looked as good. So you have the lines here in yellow. This is what the residual circulation track is, but as far as the radar is concerned on the velocity data, it's just not there anymore. So that's good news, though. That means that maybe we breathe a little easier out here in southwest Oklahoma. We could still have a redevelopment of one as the parent circulation center is still there. But for right now on radar, honestly, this looks much better than what it did moments ago. So fingers crossed that is going to be the case. Look at a couple more things here on the radar. Oh yeah, even the rotation tracks. So let me show you here. So this measures the significance of the rotation within the mesocyclone. You see how it was these little brighter red and yellows here, right on the west of Dotson. See how it went through on the west-southwest side of town, and then the east side of town, and then now it just kind of disappears, right? So that's kind of where we are right now. So that's a downward trend in the strength of this mesocyclone. So we'll keep an eye on it, though, because in case it does decide to redevelop a new tornado, that does happen on occasion. And stay obviously in your shelters if you're in Harmon County and you're right around the town of McKnight, between there and Dotson, Arnett. Stay in your shelters because it could produce another tornado. The good news is right now it's not, so that's always positive. I like to call it as I see it. So we take it, minute by minute. Let's see. Let's take a look back up here to the northwest Oklahoma again. Cluster of storms there. Let's take a look at this Arkansas City and this Honeywell. Make sure there's nothing going on with these guys. Okay, they're all behaving. Again, Arkansas City was the other tornado warning out here for southern Kansas. It also did not produce a tornado. It did have a funnel cloud, I think at one point, and it did have a wall cloud for sure, but it didn't, never did produce a tornado. So that's good news. But it is in the area where it could, and it looks healthy on radar. Let me see what this latest indication was. Rotating wall cloud right over Strother Field on looks like airport. And this back rotation here. So, in other words, it's a good healthy storm and has the look that it might potentially try to do something here in the short term. So keep an eye on this, guys. If you in southern Kansas, if you live north of Arkansas City. So let's get some highways on here. Let me put this thing back on. And then let's see. So this is right along Highway 77. This is on 71st Road and also 242nd Road. So that's the intersection of where this hook echo is here in southern Kansas. So that's what you have to watch for any potential traffic development. So it'll be running eastward right along 242nd Road for a while, and then we'll see what happens. It'll have a little jog to the northeast from there, but that's the general vicinity for the next few minutes. So we'll keep tabs on you guys up there in southern Kansas. It's a pretty classic shape to the supercell structure to it. All right, so let's go western Oklahoma. All right, so we've got some storms coming into Sweetwater, just a heavy thunderstorm boosted to big hail, a lot of lightning with that one. Back out east, let's see here, probability of tornadoes at 4% for the sky up around the Clinton area. Let's see if anything's changed in the structure. Ooh, data is not good. They switched some radar on this one. All right, let me go to this other one. Let's go back down here. All right, so far, we do have some broad mid-level rotation between Clinton and Arapahoe, but that's not a big deal. This is also looking at 9,000 feet, about 83 miles away. Okay, we'll see if that other radar has gotten rid of that nasty scan it did a minute ago. See all this range folding is the purple colors. That means that they probably changed some of the settings on the radar, and so this first scan that came out was jacked up. So we'll wait for the second one to come in. Let's see. Weather Services noted the rotation near Harmon has weakened considerably, or they used the word markedly. All right, so we already discussed that, so that's why I wasn't too worried. We'll watch, see if it changes. All right. So right now, we have 2 active tornado warnings, but neither one are producing a tornado. Obviously, though, when you're in a tornado warning, you want to stay in your shelter. At the bottom of this broadcast is a crawl, and this crawl runs all the time. Same type of information. It's the lowest level, center part of your home, away from all outside walls and windows. Never ride it out in a mobile home, manufactured home. You want to get in a sturdy shelter for a tornado. All right, let me see what I got going on here. We're going to have to go back and forth between the Kansas City situation here. Let's see if this is changing any. And let me do the following. Let's come up here, switch radar sources. All right. So again, we're talking about 242nd Road, which is east of Highway 77, is where this particular circulation feature resides. And let's take a look at azimuthal wind shears, about where it should be, and gate-to-gate shear is non-existent, so again, that's a good thing. All right. So in this particular case, like always, you stay in your shelters and you wait for the storm to pass, even though it may not be producing a tornado at this time. And in this particular case in Winfield, south of you guys, it is not at the current moment. Hail size up to around 2.5 inches in diameter, though. So that is a healthy supercell storm just across the border. All right, other storms down here in northern Oklahoma, those aren't even severe at this time, so that's good news. We'll keep an eye on those as well. All right, now again, we do have these storms down here into western Oklahoma, so let's do a little look at these. All right. So again, just a little bit of a weak circulation between Clinton and Arapahoe. Just looking at the helicopter shots from that, and it's a very ragged, very slow moving updraft, which borderline wall cloud. So nothing imminent or anything like that. Some scary looking clouds at this point. All right, let's see here. Let's go back into southwestern Oklahoma. Let's see if this guy's changed any from Dotson. And no, it is completely fallen apart. But it's got a lot of wind kicking out of it. That's for sure. Let me do that. Let me go show you the wind speeds. We can estimate these. So a lot of scud, scary looking clouds in there for the Clinton area. And that's all those are, by the way. They're just sitting there. And they're not rotating. It's just called scud. You get scud on almost every thunderstorm. So it looks scary, but that's all it is. Okay, let me see here. Let's go to the wind. Oh, this is so lame. It's not picking it up. What's the distance here? Might be too far away. Let's see. We're 51 miles per hour is the wind. And we're at 53 miles, 4,000 feet. Don't know. Interesting. Downdraft gust potential is up around 70 miles per hour. So there's a lot of energy that it takes to get these storms to grow tall. And if you have a collapsing cell, that air that goes up must come down. And the radar does estimate that could be potentially up to 70 miles per hour. So hence the wording in the threat today for severe storms to have winds up to 80. These guys up here, same idea. They're up around 70. There's mid 70s. So between 70 plus, anytime you get a cell collapse, so that's how you can have some damaging wind. So just took a look at that. All right, so you're here in Oklahoma City, you're going, what's the deal? Anything for us? Answer is not yet, not now. It's 6 o'clock, and it's going to be a couple hours before this stuff out here in western Oklahoma gets into, the northwest side of the metro, assuming it moves kind of on an eastward track. And it's going to turn into kind of a flash flooding deal. These storms really haven't moved much. Matter of fact, let me go do an animation of this. Let's go back to this guy. Let's see how much they've moved. All right, so you can see they've kind of clustered together. Kind of a general west to east fashion with kind of a north drift. and very slow. So that means there's been a lot of rainfall in this area. Probability of a tornado, by the way, is only at 2%, so still quite low. I don't expect the algorithms to do very well at putting a big probability for a tornado. Matter of fact, let me see if I can go back far enough on this guy when it was around Dodson. And let's see what the algorithm did when it was here.
Just north of Bremen on I-35, watching this wall cloud, it is rotating. Brief funnels, very brief.
All right, so we'll get to
Bowl-shaped wall cloud.
We'll look at Jeremy's feed. So the most this had was about 6-7%. All right, and that was when it was about to produce a tornado, or was just near the Dodson area briefly, and that's it. So I don't expect these algorithms to do very good. This is kind of a hybrid summertime type situation than our typical spring. So we have a lot of weaker wind shear. So this is probably not going to be very robust as a result of that. All right, so let's go up to the north and let's take a look at his feed. So let's go here. All right, so he is in this vicinity, checking out this Honeywell action. So he's up I-35 near the Kansas border. So let's take a look at his feed. And let me refresh. So this is a picture he just took a minute ago. So that's the wall cloud he talked about. So good view of it. He said he could make out little fingers coming out with little funnels. So that's not surprising. Let's see. Here's a close-up view. And this is the live video. Thanks, Jeremy. I've got your live video up. So with sometimes cell phone connection may drop in and out. That's what we've got there. All right, so he's lost connection, so we'll wait for his. And then Chance was also up in northern Oklahoma. I think at some point he was going to go across the border into Kansas. So I think that's the last I heard, that he was heading into Kansas to try to catch that storm. But he may have, for our Kansas City, but he may have waited on this one to see if it was going to do something. So we probably have a couple of guys on the same storm, and we'll check in with both of them here as we go. But you can see here on the map, you're starting to get, let's do this here. You're starting to kind of get this little hook appendage, so we'll see what that ends up doing, if anything, in that area. Yeah, there's a little bit of rotation couplet there on the radar. Not very strong, but it's definitely there. So we'll see if this one turns into a potential tornadic situation. Probably a little bit tornadoes at 2%. And then let's see there, Kansas City. Let's go take a look at that one. Let me switch radar sources. Hook echo, still nice on the radar. And yeah, velocity today looks a lot better than what it has in the past. Probability of a tornado is now at 5%. And it's not quite there. It's getting closer, though. Potentially producing a tornado. This would be east of Hackney, by the way. North of Parkerfield. Let's see. So it's running right along 234th Road and 111th Road. This is in southern Kansas. So that's the center of the circulation. The track on this would take it toward Dexter here in Nicali County, north of Silverdale, if that were to end up producing on the ground, which I guess is getting pretty close. We're finally starting to get some gate-to-gate velocity data within this. So it may just be a little bit matter of time. Here's the this little yellow line is the track they did for the bottom end of the hook echo. So that the storm, potential tornado part of it, would probably just north of this little yellow line, closer to the tip of that hook. So it'll probably run just north of this line. So if you live along 232nd Road that runs east and west in Kansas, that's going to be for that one. All right, so let me see this guy down here in Honeywell, different perspective. Yeah, still trying to do something. We'll see what happens with that. And that's it. So we'll keep an eye on these two up here in the southern Kansas. All right, let's go another view of that one. Back here, let's take these out. These are okay. All right, now I'm back down to southwest Oklahoma and out here in the west to see what's happening with these guys. He claims he had a brief touchdown of a tornado. Let's see. Not sure I would buy that. All right, let's see here. What does the data tell us? Doesn't look all that great. All right. So still not quite impressed with the stuff around the Weatherford to Clinton area. So as far as producing tornadoes, it's a good strong cluster of severe storms, though. We'll have a lot of lightning with it, a lot of hail, and yeah, it's had wall cloud with it at times. So we'll see what happens with that. All right, let me go southwest Oklahoma to the corner. Let's see what's happening with this McKnight-Dobson deal. This is down in Harmon County. Let's see here. Nothing. That thing gusted out, lost whatever was the center circulation for it, and never got it back. So it's just, there's nothing imminent on tornado genesis at this point in time. So we'll see what happens with this cluster that's coming out of the Texas Panhandle as it moves east, if it ends up trying to do something new and different than what we've got going on down there. So we got some time to let that iron itself out. Stuff up here, again on I-40. One of the aspects is, let's see, this is around, the radar beam's up around 7,000 feet, so it's hard to get really good low-level circulation features that'll show up. The column of a tornado, as far as the depth is concerned, from ground level, is for radar detection really is up to about 5,000 feet. Once you get above that, it's going to get a lot harder to infer and or detect. So I like the radar beam to be around 3,000 or lower. So that way you know you're tracking the column of air. Anything higher than that, I think there's a error you've got to take into account with that. So in other words, we don't have the best low-level sampling out here in western Oklahoma, radar-wise. This was the long version of that. I'm going to launch a new radar window. So I'll have 4 different guys running at once. And I just beefed up my computer so it could handle it. I'm testing out this i9 12,900, what was it, K or whatever, CPU. Let's see what it can do. Come on, Intel. Let's see here. Okay. We are, distance-wise, 73 miles. It puts us at 7,600 feet. Still too high. All right, so that's not going to give us a whole lot of help until it gets closer to a radar system for low-level scans. These guys, they're about 3,700 feet. Oh, no, let's go down here. 8,000, worse. All right. So in radar meteorology, when you really want to track those low-level circulations, there are parts of Oklahoma that just don't get good coverage. They're kind of in no man's land. Unfortunately, the ones out there in western Oklahoma are in no man's land. Right along I-40, that little corridor between Elk City to Weatherford is just, it's unfortunately not a great place to get storms because we can't see very low to the ground. So that's the issue there. And so you have to do a lot of inferring, right? And you have to do a lot of, let me check something. Let's see here. Don't mind me, I gotta take a 30-second break here so I can fix something that I noticed. And then I'll be right back with you. No, that looks okay. I'll leave that open. All right. Sometimes you got to talk to yourself to work it out because you got too many things going on. Well, let's see. Back out here, let's go to that western Oklahoma deal. Let's see if these storms look anything different from this radar view. All right, so this area is likely some side lobe contamination out here, so I'm going to ignore that one. But the one that's right around Indianapolis, there is a little rotation within this. It's not producing a tornado or anything. But the mid-level rotation, which is what the radar is detecting at, where are we at, 7,400 feet, is decent enough. So we'll watch this leading edge here of this storm that's northwest of Weatherford to see if it gets its act together. It's still got a long ways to go, but it's, you see this is the difference. Let me show you what matters, right? Okay, let's just do this. A little drawing tool out here. We'll do this guy. So anytime you have kind of in this shape of what's trying to become a hook echo on a storm like that, right? And then here's another one, this guy here. He's trying to do the same thing. All right, so this is two supercells. And the area when you see this, of where you're looking for a potential tornado, is always going to be right out here, okay, on the edge of the hook echo. And then what happens is, if things go well, then you get a tornado that develops out of both of those. Now, what happens is these supercells will have to kind of get a little distance apart from them, and the hooks got to come a little bit different oriented than they are currently. But that's how you would end up tracking two tornadic producing supercells. Now, is this going to happen with this one? Probably not. We still have a long ways to go, and they've got to get way better organized than this. But that's just an example I was going to give you that we're watching here in this area. Now, if we go back into Kansas, and we'll take a look at that. So here's an example where the orientation is different. So if I were to redraw our circular pattern here, and it comes down, and it comes in like this. All right, so now it's much different look to it. This now has this more of a fisherman's hook rather than just a little notch dropping south. So now that it's curled back in, that signifies processes that have happened above it to get this structure to take shape. We call that, there's a lot of names you can throw around. B-weir is one of them. But the point being is the wind structure has changed to allow a better opportunity for producing a tornado. So if I go through time here, let me back this up and then go forward. All right, so right here I'm looking at the velocity data right there. So there was probably had a tornado on the ground. This is on 212th Road and 141st Road. This is just north of that 232nd Road out here, probably in some farmland. If I turn this off, yeah, just over open farmland, didn't hit anything, just some nothing, grass, trees, hay, whatever. All right, let's put this back on. Let's see, and if I were to look at the strength of this, let's see if I can. Let's see. Yeah, I might be able to. All right, let me go to the next scan. It moved to the northeast, northwest, and then weakened. So now it's actually back in this area. Now what you've noticed is this little line here was adjusted. So the Weather Service saw that notch in the in the velocity data and then redrew the track line based off of it. Now the problem is that the tornado that was kind of in that area kind of did one of these and then died out. And a lot of times they do that. When they go to weaken, they just kind of jot curly Q kind of back to the northwest and then fizzle. When they're holding their own, they'll keep on that track to the northeast like this line was going to have it do. So if we go back, this is how that played out there into Kansas. So it did a little loop-de-loop, and now it's gone. Now another one may try to take its place, but that's what happened. If you look at the probability of a tornado, look at that, 32%. When we're back at this method here, it was 30%. And let's see, here was 10%. So it ramped up quickly from 10 to 30 to 32. And it produced that little brief tornado, and then that was it. It's done. So this is how the algorithms will work when you're in a situation where it's a lower probability environment, because you have to have some really favored things to happen to get one to go. And that boundary is one of them. All right, so the Weather Service put out a statement, probably because it kind of calmed some of the storm chasers down that are saying they're seeing tornadoes, and they're mentioning how when you get an RFD surge, which is a big rush of wind that comes down out of the back end of the storm where the tornadoes' hook echoes reside, it's a one-way wind. Well, it comes into an environment that already has a south wind along it, and so you create a little shear along the leading edge of that, and if there's still some updraft residual, you can get a little spinning along it and pull up some dust, right, that looks like a little circulation that goes up. And so that can be called a tornado from someone viewing it, when in reality the process is different. Anyway, they're kind of pointing that out. All right, let's go to these guys here again on I-40. Still nothing yet. We'll just keep an eye on it. Probability of a tornado is at 6%. So it has gone up slightly. All right, let's go to southwest Oklahoma. See this guy in Hollis. Now remember, the tornado warning that was in effect has been dropped for this area. They just replaced it with a severe thunderstorm warning. It's got some big hail. When you see white on the reflectivity side, my goodness, man, that is some big hail. So you want to see that right there? You see what that number says? 4.05. You can read that. That's 4-inch size hail is what the radar is detecting. If I were to look upstairs, because I'm curious, whoa. So this is a three-dimensional view of the hail core. All right. That is some intense, because I'm at 60 dBz. I have to go all the way to here to get 71 dBz to almost eliminate all the reflectivity values. Those are some huge giant stones, man. Giant stones. So that's some big hail out here in the southeast Texas panhandle from this guy. So I think on my blog I mentioned hail sizes greater than 3 inches. So there's an example with that one. All right. Oh, the velocity data is trashed. Let's see. So let's close this. Let's see what we got here. Now, the algorithm put this little triangle to signify a tornado vortex signature, but it's only because its velocity is trash, it's garbaged, and so it's a false trigger. But you can see all these bright colors here. This is your rotation tracker, basically, if you will, and because of the issue with the velocity data, it threw off those algorithms. So we'll have to wait for the next scan to calm down. Probability of a tornado is only 6% in this area. So we'll see what happens down here in southwest Oklahoma. Right now, it's just a really big hail maker coming in to the west side of the state there. And that trails on back on into the southern Texas Panhandle. All right, so let me see. Let's go back to, let's go to Wichita. Again, we're having to do a lot of back and forth stuff just because these are splitting so many large volumes of area. All right, let's see here. So this one here in Wichita is trying to reorganize into another weak mesocyclone, which may end up producing a tornado. It's got another couple scans to go before that happens. The let's see, is this still 232? Let's see, 212. This is 212th Road, and the one north of that, does this show up? 202nd. So between 212th and 202nd, just west of there on, what road is this? 181st Road. So that's where that developing secondary mesocyclone is, which may eventually produce a tornado. Right now, this is what the structure looks like on the reflectivity. So it has a nice little bowl on the hook echo, so it looks stout. Probability of the tornado is at 24%, so it's dropped from what it used to be. Let me see if I picked up any debris on that one before, and I think we did right there. Let's see. Nope, we didn't. No, we didn't. It did get a little light. It's possible this little green area here, it's possible it may have at that point in time picked up something out here. These little grass, this little tree may have hit that and lofted it up, but it wasn't, because it's over an open area, there wasn't much for it to pick up. So as far as the radar detecting anything that's non-hydrometeor wise for a target, it didn't trigger much. So again, if it was a tornado, it was brief and it was over that little open area, and that was it. So that's good. That's where we want them, right? We want them away from nobody, last for a very short period of time, and do no damage. So Weather Service is talking about the big hail coming out of that storm here in the eastern Texas Panhandle. They're talking about wind-driven hail. Well, we saw the size of that hail. That was ridiculous. Matter of fact, let me see if this will show. I might need to switch radar views. Let's see, what am I on? No, I'm on this one. Okay. Let's zoom in and see if it'll plot it on here for you. So there you go. Hail, the hail core. Here we go. We basically just tracked the hail core. Hollis at 653, which sounds like a long time to wait. And usually the hail core will drop by then. And there's Gould after that. Gould. Let's see. But the hail itself detected is 4 inches in diameter. So there you go. That's a pretty significant event, if you ask me. So we can get, obviously, a lot of destruction with that situation. Let me look at some of these winds. Let's see, we're on the Dailiest. So we're looking at 63, almost 70 mile per hour winds on the leading edge of this line where this hail core is coming out of. So that's why they're talking about wind-driven hail. So, might be a little destructive out there in western Oklahoma. So, for example, if we had 60 to 70 mile per hour winds with 4-inch size diameter hail storm moving into Oklahoma City Metro, total devastation. You're talking about millions and millions and millions in damage because that would be a nightmare situation. So luckily, we have a big state with a lot of land, and sometimes these storms, they get ugly, but they get ugly over areas that's not necessarily affected as much. All right, let me look at streams here. So looks like let's see, is he still up? He was. Got a picture of his drone. That's a new thing, by the way, is putting drones into supercell storms and tracking to see how they're going. Okay, so he's still watching that stuff up there in northern Oklahoma. He stayed south. He doesn't leave the state. So he's lost his signal. Okay, we'll get back to him. Let's see. What Chance is done.
Here now on the base, showing 2-inch hail, a little bit bigger golf ball as possible. So we heading right on the border right now. Look at that lower end developing. Right by that tree.
So he's still on the Oklahoma border.
Looks like it's going to go towards Honeywell and South Haven. We'll see how far. I've been watching this.
All right, so he stayed in Oklahoma after all. At one point he was thinking about jumping into Kansas. So let's go take a look at the storm he's looking at. Okay, so actually, believe it or not, he and Jeremy are probably near the same location, checking out this stuff back here. Let's see here. This is a mess, and velocity data is very weak. So it's going to have to do some miracle development here to have something happen out of that. But both those guys are watching it in that area. Okay, let's do the tornado in Wichita again here real quick. What's happened with that? Probability of the tornado has dropped to 9%. The rotation area is still there, but it's very weak. So we'll see if it does anything. It may not. That may have been it. The little one brief tornado detection, and that's all she wrote. So we shall wait and see what happens. This again is in southern Kansas, run west to east in Cowley County. So slow mover. Other storms back behind it, but those are not tornadic. They're just heavy thunderstorms. All right. Let's take a look at the I-40 corridor. Guys out here in Weatherford and Clinton. So nothing has changed with this configuration. These are just some healthy thunderstorms. Nothing to be concerned with as far as anything tornadic at this point in time. Again, you're going to have a lot of scary looking clouds as usual, but that's about it. All right, that just leaves southwest Oklahoma. So let's go back down there. Oh, wrong one. Not that one. This one. All right, so this is a storm that's moving through Hollis, McKnight, come out of Texas. Wow, just a lot of range folding on the radar data. That's some big winds. I'm going to go and look at this other view here. See if we can't get some of these values. Let's see here. All right, we get up to around 51, then it range, then it folds over. And that's the peak wind here is 33. So the scale goes to 50, looks like. All right, so 50 back down at 33. So that's 65, 67, 68 miles per hour to add those together. Oof, it's ugly.
I'm up here at this way station on the Kansas border watching this Caldwell storm. This rotation's really coming up hard.
Gotcha. I just had your feed a minute ago. Thank you. All right, so that was Chance. He was looking at that stuff up in northern Oklahoma and across the border. All right, so the winds down here are still up around 60 plus miles per hour, which is what I was trying to look at a minute ago for the wind-driven hail. And because the environment is so crazy right here down here, it's throwing off all types of false alarms. So it's going to be a little chaotic to get some true data that's not contaminated.
I'm like 2 1/4 south of 166 on I-35 at the KDOT way station.
All right, let's go. Where was he? Okay. So he's back here looking west at this tail end of this guy. So he's near Honeywell, looking westward. So let's see what his view looks like. So he's looking at this little lowering right here. So this is a lowering.
We've got another developing wall cloud near Honeywell, Kansas, right on the border.
Thank you, sir. All right, so Jeremy's also on this same storm here. So you can see how that wall cloud developed here, broadened out on Chance's stream. Let's go to Jeremy's. Refresh his. So this is just a still picture of that same video. So there's a wall cloud going. So he's got he's got his camera right here to videotape it. And take some really good still pictures. But anyway, so this is what he probably just from his cell phone. This is what he's got up there, just on the right along the Kansas border. You need to get that drone of yours going live. Now that would be something to see. All right, so we'll check back in. Let's go look at the radar again.
Aaron, we've got a funnel. We've got a funnel.
All right, so that was Jeremy. So let me see if he has live view up. I don't think he does. So we'll go to Chances. Okay, I don't have your feed. I do see a still picture. So if you get your feed back up, let me know. And I think that may have been the funnel in his. It's hard to see from this angle. That little bitty dip right there. Depends on how far away Jeremy is. But yeah, so there you go. So there might be getting a developing tornado up here along the Oklahoma-Kansas border. We'll see what happens in this back edge of this supercell storm. Probability of a tornado, though, is at 0%, so it doesn't have much going for it in the indices at this point in time. Let's see how that one looks. Let me go to the other. Let's see here. So this is the old tornado warned storm toward Dexter. Still nothing on radar. We're at 3,000 feet elevation, so we definitely see something if there was something notable. So again, stay in your shelters always during a tornado warning, but the good news is there has not been one for quite some time for this one coming in north of Dexter. But stay in your shelters for that if you live in southern Kansas. Okay, so back down here, another view of this guy. All right, we'll split the difference on that view. So what we really need to happen is this bottom end here needs to start to develop more of a hook echo appearance, and it's just too linear north-south. And once that happens, then producing a tornado should be easier to do versus now. But there's a nice view from Chance. Let me see if Jeremy got his up and running yet. Nope, not yet.
That was gonna lift off the northeast and
So he's just going to watch this whole lowering and then look for anything that may drop out of it. And that's again in far northern Oklahoma near the state line, just west of I-35. Okay, so let's go to a little quick view here of our guys from Weatherford to Clinton. Let's see. Interesting. I guess technically it could happen. There may, let me see here. Yeah, there may have been a brief, still may be, a weak tornado trying to develop here in the back edge of this whole mess on Highway 54 south of Thomas, and Crossroad is, come on, give me a crossroad. No crossroads? No crossroads. Well, this is 33, so we're looking at 2 miles south of 33 on 54 is where this thing is, kind of in the vicinity of. I don't know. We'll see if it does anything on the next scan, but there's at least a couplet in here, but it's buried within the rain. And usually on the back end of this stuff, it's a freak occurrence if that even happens. But it's there, so we'll see what happens with that. All right. Nothing else, though, within this cluster catches my attention. So I'll come back to that in a minute. All right. Let's go to southwest Oklahoma. All right, so warning out here continues for this supercell storm, producing a lot of wind and hail. Man, that radar data is just chewed up. Let me go to this guy. Man, environmental wind is crazy. It's like 40 miles per hour inbound and 50 outbound. So just the wind field within this, it's just going nuts. Let's see. The shear overall is still relatively weak, but it is directional though. Okay, so this is still just basically a big wind maker, is what this is right now. Man, these little bitty eddies. 1, 2. Because what the Weather Service mentioned earlier, I talked about, there's so much convergence and shear along this mess, you can get up these little swirls. Probability of tornadoes at 26%. That's actually pretty high for this storm. And honestly, I don't know. I'd be. Let me see. Oh, is this data updated yet? Yeah, it has. Let me go here and look at different height. Yeah, I'd have to lean toward a tornado on this one. That's East Road 1570 and North Road 1750. So probably a weak tornado there. Now, there's not a tornado warning out for this, but it looks good enough for me on velocity data on radar. But that's probably likely a small tornado there because the velocity is not intense, too intense, I should say, but it is present. Yeah, your rotation tracker even has it there. And this flank on here on the front end, another one might be there as well. That one caught my eye, and then there was a middle one here, but I think that one weakened. It's just there's a lot of shear along this whole leading edge. It wouldn't take much just to spin something up real quick. All right, new data came in. That one weakened quite a bit. The radar's still having some trouble with contaminated data, so it's going to bring these values up and down. This guy here, though, still looks around south of, let's see, what's this marker? 3.4 inch size hail. Now that is still there. It's got a good spectrum width with it. It's currently over open farmland. Let's go. Yeah, it's in this little area here. So that's a good spot for it, right? So that might be a small trying to develop tornado if it wasn't just a very small one briefly a moment ago. It's a very weak signature though, so it's not like it's anything crazy. Overall though, the storm itself is just a big hailmaker with a lot of wind in general. So it's just a big windy storm. What looks like an embedded tornado to me. And that's southeast of Ignite by 1, 2, 3, 4 miles east-southeast. Let's see, this new probability of tornadoes at 18%. And that circulation feature is still there and is in a donut hole of reflectivity. In other words, a much lower value. It is very suspicious. Oh, well, the Weather Service is going to issue a tornado warning for that. Go figure. All right, so there we go. We got our tornado warning. After I've been talking this for 5 minutes. It happens that way sometimes, though. You focus on a lot of different things. You saw how many storms we got to look at all at once. So anyway, so that I was right. That was a tornado, and it still is. This is on East Road 1560 and North Road 1760 in Harmon County, northeast of Hollis, northwest of Gould. So, good job, Aaron. Hold on a second. I don't know, man. Sometimes you sit there and you go, that's not even, when it's a cluster like this and it's not your classic setup, you have to second guess a lot of stuff just because dynamically the way things are made in this, it's messy. So anyway, so that's looks like a tornado there. Let me see if it's got anything on strength. Why is this not working? Oh, I think I know. Oh, I think I know. That's a problem. All right. Okay, so let me see what else we got going on. Let's do this first. So the track of this is, luckily, it's not affecting any major community. So that's the good news. It does have a tornado vortex signature. And moving to the east at about 14 miles per hour, also has some hail up to 2.75 inches in diameter. Again, this is well north of Gould, so there is no immediate town or city or anything in the immediate path of this particular storm. But that's where that would be located. All right, let me back up to the north real quick. See how this thing's doing. And let's check out their feeds. Alright, so he's bailing on that to get either a different view or just kind of keep up with it. This is in northern Oklahoma, and that's for this guy right here around Honeywell into Kansas, right on the Kansas border. The other storm that was tornadic up here at Dexter has since expired. Never did anything, so they let it go. So we'll see if this one here tries to produce a tornado. So he'll probably stay with that one. We'll keep an eye on that one for you guys in southern Kansas. Okay, so let's go back to this guy here, Thomas. There was a little weak circulation couplet there that lasted for just one radar scan, and it was gone. So, good riddance. It may have been a little weak, trying to become a little weak tornado, and it just didn't quite do it. It's fine with me. And that's it. That's in this mess up here. So, otherwise, this storm along the I-40 area to the north isn't much to write home about as far as anything, of that caliber. So really now, other than just the fact you've got your standard severe thunderstorms here, kind of hit and miss, the biggest story now is in southwest Oklahoma. And that's what we talked about a little while ago. So let's see if we can't get a secondary circulation out of all this mess. This one looks like it's starting to weaken a little bit. Now over East Road 1550 and 1760. So that would be that weak tornado there. Yeah, you see the new line, this little yellow line just came up. So in other words, the Weather Service just updated the track based off that position I just gave you. But the newest data dropped it. It's gone. It's done. So that little weak tornado that we tracked for the last 10 minutes, I guess, circulation area has pretty much now diminished. And then we'll have to see what else happens. This guy here, let's see. This new one, between McQueen and Gould, may have another little spin up along the leading edge. Let's see. Oh, it's in a noisy area. It's not co-located. By the way, I'm going to go back in here for the old circulation and look underneath. So it traveled through this no man's land, literally. Perfect place for it. Nothing out here, just some trees. Maybe a cow. Alright, that's what I like to see. So far we are 2 for 2 on tornadoes in the middle of nowhere. Thumbs up. Okay, let me think. Anything else? The hail within this has come down quite a bit. I'm going to look upstairs. So, still stout hail cores hanging off a loft up to 35,000 feet. But let's see the value. So I remove all value at, where am I at? 65 dBz, 66. So earlier we were at 73, I think. So the hail size has come down quite a bit compared to what it was. So if it was 4 inches before, we're probably talking about 2 inches now, maybe 2.5. Let's see, what does the algorithm say? 2.87. So there you go. All right. This thing's trying to form kind of a little bit of a hook echo on the leading edge of it. So we'll see what happens with that. All right, but this tornado up here again is gone. It dissipated. Let me look at another radar view here. Yeah, it's still gone. Didn't come back. So again, we kind of lucked out for our normal active tornado season for May. We really did not have that much of an active season, and we peak in the middle of May, and we just haven't had that kind of stuff here, and that's a good thing. You know, we had a couple of days really this spring, and that was it. So that's a positive. Of course, the last day of May, you know, Mother Nature throws in a tornado, of course, because that's how she rolls. And we might be in an active pattern for at least, you know, in June. We always say severe weather season around here runs from about mid-March to mid-June. So we usually just pick the 15th. So March 15th to June 15th is our typical severe weather season, in which we usually deal with some tornadoes peppered in amongst all that. So we'll see if that materializes here this time around. So my point being is that we may not have our finished severe weather season. It may still have another couple weeks to go. Okay, so let me go back down here. So again, we'll see if anything comes out of this area that's west of Duke, between there and Gould. Right now, it needs to do a little bit better organization. Let's see, time on that. Yeah, that's good. All right, more storms trail back from this one into Texas, just so you know. The ones up here into west central Oklahoma have barely moved. I'm going to go pull up the rainfall totals for that area, because I bet you there's been at least 2 inches of rain. And then I'm going to look at that one here in northern Oklahoma again. Oh, it's just about out of the state. Tiny tip of it left, and it's now basically a southern Kansas storm. That hook, though, you see how it's still vertical? It's linear like this. It needs to curl under itself. It needs to do a little curlicue. It's not doing it. So until it does the curlicue, it doesn't produce a tornado. The orientation is not correct, and that may take a while, or it may never do it. But anyway, that's the only real storm to watch up there in that area. I'm sure there's a bunch of storm chasers on it hanging out. Okay, so let's go. What was I going to do? Oh yeah, flooding, rains, etc. Okay, so let me do this. Let's turn that off. And let's see what I can find here. Yeah, well, that's kind of what I figured. All right, look at that. Whoa, that's even more than I guesstimated. So this is what happens if you get trailing supercells this time of the year that are slow movers and don't move much. Look at these values. From Thomas, between there and Clinton, leading Putnam, Foss, Elk City, that little quadrant here, Arapahoe, Butler. I mean, these are some horrific amounts. I mean, horrific meaning because you get flash flooding in those situations. Hammond and Butler got hit the hardest, and just north of you guys. So that's radar estimates of over 5 inches of rain, almost 6 inches of rain. So on the model data that I showed you on the forecast, the models are good at picking up on this potential. They just don't know where to put it. Like, they kind of have the idea, And by the idea, I mean in the area, as in the vicinity. But as far as going, nope, it'll be right here in Oklahoma County, or right here in Canadian County, or right here in Kingfisher. They're not that good. But you always want to see what the take home is on the data. And the take home was, you're going to have somebody that's going to get some ridiculous amounts of rain that can have, 7 inches of rain. And yeah, that happened. Now, did it happen in Oklahoma City? No, it didn't. It happened out here in western Oklahoma, just north of I-40. But could you imagine that kind of rain, though, in some, populated areas with low-lying, regions? That's a mess. All right, so the Weather Service will cancel the tornado warning because it hasn't produced a tornado in a long time. For that one that we tracked a while back, that you heard here first. Just so you know, there was nobody talking about a tornado there in any of the news stations. I got them all running for their helicopter shots and stuff for visuals, and they didn't have anything. And of course, there was no official warning when I first looked at it. But all that can change pretty quickly in this environment. And unfortunately, you can kind of get an idea. You just have to keep going back and forth, flipping through different radar views, right? So it can be exhausting. It's pretty taxing. All right, let's look up here in Kansas. Probability of a tornado is at 3%. So nothing imminent there. And I'm pretty sure my guys I think Jeremy probably just bailed on it and let it go. I think he typically just stays into Oklahoma. So yeah, it looks like he just let it go. And then Chance, he looks like he's probably still trying to keep up with it. So we'll see what he does. All right, let's go back down to southwest Oklahoma. And we'll just focus on, really, the only storm right now is this guy here west of Duke. Probability of a tornado has jumped up to 49%. Now that's a big jump because it was at, well, no, it's 55 last time. Okay, this one, 18, 16, and then just went to 55, and then bam, 49. All right, so in other words, the structural integrity of this guy is starting to change a little bit, so that might be why the algorithms are getting a little more excited. Doesn't mean it'll happen, of course. It just means that the parameters have increased for that potential. A lot of shear in that area, but nothing tornadic yet. The area to watch would be west of Duke here on Highway 62. Let's see what else we got going on. Hail down to 2.81 inches in diameter. Let's throw on some of the indices here. So let's put this on. Let me zoom in. Let's see if there's going to be any towns that'll show up. No, it's old. Let me do this. Downdraft gust potential up around still 70 miles per hour. All right. Let's see, the RFD on this thing is up around 59 miles per hour. So you have a lot of azimuthal wind shear in this little quadrant that shows up here in these little values. But one little spot here of gate-to-gate shear, but I think that's going to be an error. But it would be in this little spot here where these colors change from green to red. So you have 42 miles per hour incoming. On the other side, you have 38 miles per hour outgoing. So this is where you would look for something to get out of control. So we'll watch for that little area. And let me see, you also see if that's co-located in the reflectivity. Ah, it's not. So since it's not co-located, we just kind of watch that area, but it needs to be, those values need to be kind of where this little hook echo would kind of shows up more. Now they can be in the lighter reflectivity values. It can be. It just depends on how the storm is structured. So maybe that little circulation I saw was something. I don't know. It's dusty, it's dark, it's windy on these live shots. Let's see. See what this little triangle is? That's the algorithms tripping on that little spot I looked at on velocity data. So if anything formed there, it was a flash. This intersection is 1870, just north of US 62 in 1870, that little intersection. It's about a half mile north of the highway. Probability of a tornado is at 48%. So the algorithms do favor this storm. So I'm looking at a live shot from the Duke area west. Honestly, it's just an overall lowering. I don't think he knows what he's looking for. It's just some dust in the background. So that would be the area we'll be watching for, though. So the algorithms did trip a TVS finally in that area. But the probability of a tornado has dropped to 37% now. There it is. Okay. So this is an inbound shear axis between McQueen and Duke. And so there is a lot of winds that go in different directions. So anything can get picked up in that dust or whatever and spiral up and, not necessarily really a tornado. That's kind of the thing. So that's kind of what we're dealing with here, which it's not that big of an issue. And honestly, the way it's collapsing, that's about to disappear. The structure is completely changed on this storm. All right, that's a good sign. So that's a big weakening sign. Let me look at the shear down there. Oh, let's see, where is it? This one. So the winds do turn with height. in this particular case, in this time of the year, the wind speeds are around 15 knots here at 4,000 feet, and 15 knots around 9,000 feet. And so if it were typical springtime, we wouldn't even be talking about tornadoes. This wind shear is too weak. You usually have to have 25 to 35 to 45 knots, at least increasing in speed as you go up into the mid-levels of the atmosphere. So what's different today? Well, obviously, for one, you can tell that this storm is struggling because of that, but you need something else to help offset that weakness. So in the forecast today, we had a cold front that was draped down here in southwest Oklahoma. So if the updraft of the storm could ride along that boundary and ingest what happens along that boundary, which is a lot of what we call baroclinic vorticity, but spinning motion, it can take that spinning motion and put it in the updraft and kick out a tornado. And so that can happen anywhere along a frontal boundary where you've got a well-defined mesocyclone from a supercell. So that's why you have to watch for those this time of the year. So it's kind of it's already hard to get a tornado to develop anyway. Now it's really hard, and you have to, get perfect conditions in this environment to offset a lot of the weaknesses. All right, this thing is closed up, so whatever potential it had to try to do something, it's lost it there on the leading edge and back inward. So it would have to do some kind of weird, funky thing back here around McQueen, which would not be typical. All right, so we're probably going to be transitioning over to what is going to be kind of just pockets of damaging wind and then some hail as the storm starts to weaken. Wind speeds, though, historically, let's see, this was 15 minutes ago, 65 miles per hour. So there you go. And this one's also 65 miles per hour. So that kind of jives with some of the winds that we were looking at earlier. All right, again, this is southwest Oklahoma. Let's take a look at those ones along I-40 real quick. Let's see, where do I want to go? This one. And they've really weakened dramatically. But they've dropped in some wind here in the blue area. That's 55, 56 miles per hour there. And middle of no man's land, but west of Greenfield. So this is on east of Highway 58. Let's see, North Road 2495 and North Road 2500, East Road 920. There's a little pocket of wind with that guy as it diminishes and loses a lot of its punch. All right, let's go up north into Kansas. Let me try a different radar. Let's go to this one. Is this the new one or an old one? I can't get that little icon. It's so rude. All right, I think it's an old one anyways. All right, let me look here. Probability of a tornado is 8%, and velocity data is not all that impressive. So if it's going to do anything, it's still got a while to go. The old one up here that was doing something a long time ago is doing nothing. So we shall see if this storm here tries to do a repeat of its predecessor, or if it just kind of just a typical severe storm, wind and hail, and that's it. All right, so we've had, I think, one confirmed, well, Doppler radar confirmed anyway, tornado in the state, southwest Oklahoma. And then we had one in southern Kansas, just across the border. And those are the only two that I was here monitoring that we caught. So I'm going to say those two are the ones that are confirmed. And then go from there. All right, so let me let's do something here because we're in a lull of any activity. All right, so it looks like Chance is probably going to give up on that storm, and Kansas is starting to get dark, but he may have just stuck with it for a while, just in case something happened. Because when you're on the chase, you're on the chase. Okay, so let's do this. Let me get caught up on any pertinent weather information. What time was this one done? 6 o'clock. All right, mesoscale discussion. Let's see here. Frontal convergence and weak low-level warm advection atop the boundary will be the primary focus for storms this evening. All right, let's see. 850 flow is expected to increase later this evening, which should contribute to some southward propagation. All of the primary storm motion will remain easterly at around 20 knots. Most robust updrafts are producing severe hail. This is expected to continue for at least the next several hours. With time, thunderstorms may develop across southeastern east central Kansas along the nearly stationary boundary that is draped across this region. All right, so that's that little box you see there, which covers western Oklahoma, central, and northern. All right, so this was the threat from the Weather Service today. That was the tornado potential zone we were looking for today as well. Of course, the timing, we've already had the storms out west and north. We still have storms to go here in central Oklahoma. It's still a couple hours away. We are looking at severe weather for Wednesday. Flood potential, well, we already saw 5 inches of rain up here north of Clinton, so you can see how you could have put a moderate red circle, but where do you put it? And I had kind of guessed north central to west central Oklahoma based off of an average of the model data, but it was actually just a little bit more west than that. Not by much, but that was a problem. Let's see. The front didn't really make much progress into the state either, so that kind of kept those storms anchored where they currently are. It will make some more progress tonight, though, and with the storms moving through, that'll help. Let's see here. Let's see what else I got of interest. Believe it or not, the tornado climatology for the environment we were in checked all the boxes for a potential tornado today. But I've noticed, I've used this a lot, and just because the climatology says historically that we see tornadoes in this environment, a lot of times we don't get them. It just goes to show you that the analogs that we use are it's neat, it's a good comparison tool, but at the end of the day, each event is different, stands out on its own. No two events are ever alike. No two setups are ever alike. No two outcomes are ever expected to be the same. That's what I've learned over the period of doing this forever. All right, let's go to the last 2 hours of low-level rotation, just so you can see where the best rotation was with these storms. So we'll go up here north first off. That's this guy up here around our Kansas City. So let me transparent that a little bit. So our Kansas City, and this is where we detect the tornado, which is where we had that little blue area right here. And then after that, it weakened pretty quick, and there was nothing after that. All right, so that's the first long-lived, low-level circulation that produced a tornado. Then you had this stuff out here along I-40. And these guys, although you did have a lot of lowerings and occasional wall clouds, a lot of SLCs, scary-looking clouds, scud, everything, no tornadoes with this. But that's at least the mid-level rotation with it that we had. Let's see, now let's go to southwest Oklahoma. And this is the mess. This thing's got rotation everywhere. Again, because a lot of the radar data was kind of garbled down here for one. Let's see here. But you do have that little spot that triggered this whole mess that we looked at here into Dobson, Texas. Or Dodson, rather. So Dodson, Texas, where this whole mess started for a potential tornado here, especially in the southwest side of town. So that's what this little blue indicator's for. And then it lifted right as it crossed over the border, whatever circulation was there. And then we ended up forming a new one. Let's see. And was that the one that was northeast of Hollis? I think so. I think it was in this little spot up here. The rest of the stuff was just a bunch of noise and nonsense. But that's kind of a way you can go back and look at some rotation tracks. All right, let me look at, from here on out, let's see what the Warren on forecast model thinks is going to be the best areas for anything that could be potentially tornadic. So it's favoring those areas right up here along the Kansas border. Ironically, it actually liked this little spot down here on I-40, but there's no storm there anymore. That weakens here quickly, and the storms in Kansas, their environment hangs on for a little while. This little sweet spot here for Kay County, around Ponca City. The algorithms like that little spot up there for potential tornadic development. So you're going to have a supercell course go into that environment to tap into that. But at least hangs on to it up to about 9 o'clock, and then it starts to weaken to pretty low. What does it do with storms in that area? Let's take a look. All right, short term. It doesn't actually put a supercell storm there until the end. That guy right there had the best opportunity. It's north of the border. Let's see what the other ones say. Yeah, I just, from what the model thinks is the best ingredients, there's no storm to really tap into it. But if I go back and forth, you can see the take home is, you see all these storms that just continue to erupt out here in western Oklahoma, southwest, etc. There you go. So we have a lot more storms to go out there in this part of the state. And eventually that'll work its way here in the metro. It's going to take its sweet time, it looks like. But we'll eventually get rain here as well. Let's see. I think that was... Let me see. Let's see what the latest HER says. All right. So it's got those storms out there to the west as well. The big blow up. And then there we go. So basically midnight plus is when the metro is going to get the storms moving through. So those storms move through at 3, 4, 5 o'clock in the morning, kind of diminish. And then here comes the secondary line at 8 o'clock, just rolling through the northern parts of the state. There's 11 o'clock in the morning. Some rough storms for that time of the day through noon. It's pretty impressive. It has a nice little helicity track with it, which means it seems to think that one of these storms is going to be producing some damaging wind and hail. Environment isn't all that great out ahead of it, so it'd be elevated. So anyway, that's the forecast model in the short term for now. All right, one more look at the radar, and then I'm going to probably sign off, right? Because otherwise, it's not much to discuss. Okay, let's see what this guy up here in Kansas is doing. Probability of a tornado is 2%. It looks like it's finally getting a hook echo on it too. Look at that. Let's see what the velocity data looks like. All right, we'll see what happens up here. Still got some time. All right, and then let's go back to I-40 area. Still got the wind going here west of Greenfield. It's up around 50 to 60, so it's nothing crazy. Typical, I would say. All right, more new storms out here in northwest Oklahoma, but again, these are not tornadic or anything like that. They're just standard stuff, but some hail with them though. That's 2-inch size, that's 2-inch size, so that's some big hail out there in western Oklahoma. And then let's go to southwest. Okay, so what's this mess here doing? Anything new? No. Nah. Alright, so there'll be pockets of hail within this one. This algorithm says 2.65 inches, so still got some good hail. But as far as anything tornadic or anything like that, there's just nothing there. I lost it a long time ago. Probability of a tornado's dropped to 17% anyway. It was at 1.55, and it almost looked like it was trying to do something then, but it couldn't do anything. Alright, so that'll keep dropping some wind and hail with it as well. Alright, so that's it. There's, at this point around, it's the standard typical hail and wind threat for any of these storms that remain during the evening. And as you saw overnight, we'll get some more. And then even tomorrow morning, we'll start our day with more storms out there in northwest Oklahoma moving east. So, Weather Service put out a statement that everything's weakening at the stuff coming into western central Oklahoma. So in other words, Caddo County and up around Canadian, just west of there. So all that stuff's weakening. It's dropping its load. So, okay, so that's it for now. All right, well, listen, thanks for watching. If you had a chance, make sure you like the video that you're on Facebook or YouTube so the algorithms know. Share it with your friends and families that they know. Kind of spread the word that there's a way to get severe weather coverage that's different than what they're probably accustomed to seeing, both either good or bad. And then, like I said, I cover the tornado threats mostly. So we'll might have to do this again tomorrow. So we'll see how the atmosphere looks tomorrow. But we are expecting more severe weather across the state. So we'll keep an eye on it. And then about 9:30 tonight, I will come back on. We'll do an updated forecast and see how the rest of it looks with the newest data coming in and go from there. But meanwhile, I'll say that, needless to say, that's all I got for you. So you guys have a great rest of your evening. We'll see you again soon. Take care. Be safe.